Okay, welcome Stephanie and welcome Morgan and welcome all of you who are watching this as an archive video. This is the webinar from week 9. So in terms of what we're doing today, I'll start out just kind of brief update on what's going on in the class and what's coming up. And then we're going to get into what's called chi-squared analysis. So pretty much up till now, in all of our hypothesis tests and confidence intervals, all of our work has been either a quantitative survey question or a yes-no question. What we haven't dealt with is the quantitative. Things like, what color is your hair? So what we're going to be dealing with today is how to deal with the qualitative survey question, where there's definitely no number and it's not a yes or no question. And now we have a couple more. Thanks, Linda and Sean, for showing up. So we're going to be doing what's called, again, the chi-squared test. There's 3 different chi-squared tests. They're all for the qualitative data, and I'll show you how those work. So a couple updates on what's going on. I apologize for not getting the midterms up, but snow happens. So I had them graded. It's so frustrating. I had them graded at about 9:30 a.m. on Thursday. And most of them were still on campus. I only had the last few to do on Thursday morning. I did them, and then I went to campus, and the doors were all locked, and I can't get in, and the building's alarmed. So pretty much our snow hit hard and took out this whole town. So finally this morning I was able to post them. So sorry about taking longer than I like to take, but again, I had them graded, I just couldn't get to them. So that happens. But the powder's wonderful here. So that's one thing, is the midterm's up. Look at your grade. The other thing is I posted the key to the midterm. So you can take a look. If you go to the week 8, where the midterm stuff was, you'll see where it's a midterm key. Click on that, and it gives a midterm and all the answers and worked out solutions and full descriptions. A couple things that I want to mention is, one is your project's coming up a week from Sunday. So you don't want to wait till the last minute on that. Sometimes data takes long to collect, and just you want to be able to show me your project idea. I've noticed that in a lot of the posts for project ideas, a lot of people are not having a hypothesis test that involves quantitative variables, 2 quantitative unknown variables. Could either be paired, independent, dependent, but it must be, when you think about the survey question, please ask your partner the survey question. And if your partner doesn't give you a number as an answer, it doesn't work. Or if it's not a survey question, it's data collection, imagine the over 30 numbers you're going to be put in this column and over 30 numbers that you're going to put in this column. And if you can't imagine numbers being put into the columns like that, then it won't work. So this is quantitative. So that's the number one thing that I'm noticing on the discussion forum, is that some of you are proposing yes/no questions. Second is due to request, and I thought it was a good request. The project discussion forum, the regular one, really got big. There were 139 posts. It was really hard to navigate. So I added a new one called Project 2 discussion. So use that one to ask project questions and to post your ideas, look for partners, that kind of stuff. So it's called the Project 2 discussion. I pinned it under the pin discussion, so easy to find. So that's just a little note on the projects. Are there any questions about the projects? Any questions? Okay, while you're thinking, just one more note, and this is more for the write-up. It might be even a little early to talk about, but this project is about a confidence interval, a hypothesis test for the difference between population means. So in your write-up, the word population mean has to happen over and over and over and over again. And difference between population means should happen a lot. So it might be that this population mean is likely to be this much bigger than this other population mean. But don't look at the individual populations. or individual samples, look them as combined. So that's important. If it's dependent, you're going to be looking at the dependent list under the spreadsheet. If it's independent, look at the independent list. Don't look at the individuals. Okay, you don't need to report on the individuals at all, but you do need to spend a lot of work reporting on the differences between the two means. Okay, any questions on any of that? So as I mentioned, I want to really make sure that you guys do great in the projects. So I'm really trying to help you out. I'm looking at the project discussion. If I have criticism, it's not because I'm being mean to you or anything. It's because I want you to do well. So I don't want you to continue on with a project that's going to be a disaster. So please take a look at my suggestions and don't take them lightly. Take them as these need to happen. So if you have a P1 equals P2 in your hypothesis, that doesn't work because it shouldn't be proportions. Okay, any questions at all? Any questions? Okay.
Can we turn it in for review? What's the earliest?
Well, the earliest would be in 5 minutes, but I think that's a little, you're probably not ready. But you only need to turn it in once.
Oh, okay.
Yeah, you only turn it in once for review.
Okay.
Once for review, and you turn it into review. Do not post on the assignment part. Just send me an email with it. Does that make sense? Or send me, if you're doing Google Docs, send me, invite me to read it.
Okay.
Does that make sense? Yeah, so I only read it once. I'll answer as many questions throughout the time, the next almost 2 weeks that you have.
But you don't
only read through the whole thing once. So that's why it might be a little early right now, unless you feel like you're done, but I doubt it.
No, I just was thinking sometime next week, but I didn't think 5 minutes.
Yeah, in other words, I'm ready.
Okay.
I mean, obviously in 5 minutes I won't be reading it because I'm doing this.
Right. Okay.
But the point is that I'll get to it within a day.
Okay.
Yeah. And then you don't want to give it to me the day before it's due because I won't. Who knows what I'll be doing that weekend, and you won't have time to make the corrections. I also noticed on the discussion forum that was the assignment the week after the project was due, where I asked you how you could do better for the project too. A lot of you said timeline, get it done earlier and get it sent to me earlier. So please follow your own advice. Don't wait till the last minute because things go badly when you wait till the last minute. Okay, any other questions? Okay, but we don't have any more new material that goes with Project 2. So chi-squared, which is what we're talking about today, is not part of Project 2. If you put it in, you're making a mistake. So you're ready. Does that make sense? It goes through, it's really Chapter 10, but Chapter 10 is kind of a collection of all the stuff you've been doing in the weeks before. Okay, so I want to talk about chi-squared, but I got to get a little water first. I get really dry mouth when I talk. Okay, so I want to talk about chi-squared. And I think I want to do it by example. And I thought about giving you some articles, doing a current event. The first thing is the assignment, the discussion post must be a peer-reviewed article, a journal. You have access to the journals through campus. If you click on the library, you click search, and you can search all or search collection or something like that. And then you can start looking for stuff. Don't just type in chi-squared or you're going to get a statistics journal, and that's not what you want. It's supposed to be something that is not statistics, that uses statistics. But it has to be, again, a peer-reviewed journal, and you can find those easily through our article, through our library. That's the best place. And post, this is what you should search for so people know how to find it. Because I'm not sure, I haven't tried clicking on a link. The link may or may not work because you may have to go through our library to get to it. And if you go to link directly, it may not do it because the library pays for this stuff. All right, so let me share my screen and we're going to do some examples. Wrong one. This one. There it is. Okay, so I'm going to do some examples. So the first one is the traffic equally bad in the north, south, east, and west shore? A count of 600 randomly selected cars in the Tahoe Basin found 170 in the North Shore, 212 in the South Shore, 110 in the East Shore, and 108 in the West Shore. Okay, conduct the appropriate test and provide your interpretations. So I want to look at this particular example, and I want to decide how are we going to come up with the solution to this. So the first thing that I recommend doing for every single thing that we've had in the last, I don't know, 3 or 4 weeks is think about the survey question. So what might be the survey question for this particular one? What are you going to ask this driver? Or what data are you going to collect about this driver? Because you had 600 cars. You're going to ask the driver something or collect the data about the car. And you can put it in your chat box or you can say it. What might be the survey question? Because that's the important thing. If you can't come up with a survey question, you're not going to be able to classify the technique to use for the question. And let's see if you guys can come up with the survey question. Okay, miles per hour. All right, so this is not about miles per hour because look what they found. There were 170 in the North Shore, 212 in the South Shore, 110 in the East Shore, 108 in the West Shore. That's the data. That's not about speed. What are you gonna look at that car and determine? Any thoughts? There's a group of you. Hopefully you can come up with it. Have you driven in? Kind of. It's more is because the car is driving at the point, right? You can imagine communicating with the driver while the person's driving. Okay? It's not have you, but it's more which shore are you in? Does that make sense? So the data you're going to collect on this first car you look at is which shore. And the answer is going to be either, so let me type this out. I think it's worth it. So again, the most important thing to be able to do for the last 3 weeks and the next couple weeks is to be able to come up with a survey question and understand what it means, what kind of data you get. So the question is, what shore are you on? Are you driving in? Any questions on this idea that that's the survey question? Okay, and notice that 170 of those cars that you asked, or the drivers that you asked, said north. Does that make sense? So there's going to be 170 words of north, 212 words of south, 110 words of east, and 108 words of west. But that's going to be the data. It's going to be those words. Any questions on this idea? So the answer is, for example, east. Any questions on that? So we can see that the answer to the survey question is qualitative. And that's what I want to get at, is we're talking about a qualitative study. Because it's 4 different answers. They're all words, no numbers, not yes, no. It's east, or possibly west, or north, or south. Is that clear? Okay, so the next thing, now that we have that, is to write down our null hypothesis and our alternative hypothesis. Okay, so unlike chapters 9 and 10, where I require you to write down the hypotheses using symbols, in chapter 11, I require you not to use symbols, to only use words. So let's write down H naught, other than H naught. Those are symbols. But in terms of what H naught is, and we want to think about this, is the traffic equally bad in these four shores? So that's the question, and that's going to be telling us what H naught is. So what we can say, and note the word I'm using, the, not the, that's not important, but the next word is the most important word, the distribution. So when you're going through with this kind of hypothesis test and writing down H naught, you must have the word distribution. Because what we're doing is we're testing for a distribution. So the distribution of cars, I guess of actually shores by cars, is, now if it's equally bad, we have a word for all being the same. Do you guys remember the word for all being the same? A statistics word. Very important word. Yeah, uniform. So H naught is the distribution is uniform. Notice, unlike chapters 9 and 10, H naught's a sentence. The distribution of shores by cars is uniform. Okay, now that we have H naught, H1 is really easy. I think you'll agree. So what is the other side of the coin? Any thoughts? The hint is it's very easy. Yeah, not uniform, and the word distribution must be there. The distribution of shores by cars is not uniform. Any questions on that? Any questions? Okay, so the next thing we're going to have to do is understand the data we're going to put in. The data we're going to put in into the calculator is going to be what's called the observed and the expected. So let me see how good I am at doing this. Always hard. I'm going to draw a table. And in the table, my headers are going to be in order: north, east, west, and oops, I kind of wrote it in the wrong order. North, south, east, and west. And then I'm going to have observed and expected. I'll abbreviate it just for space reasons. Okay, observed is really easy. So what was the observed for the North Shore? That's supposed to be easy. Yeah, 170. And the observed for the South Shore is, where are we, 212? The observed for the East Shore is 110. And the observed for the West Shore was 108. The expected is only easy if you know what to do. All right, so if the distribution is uniform, then how many cars should we have in each of the four shores? How many cars should we have in the North Shore if the distribution is uniform? Any thoughts? Yeah, 150. And hopefully, Sean, you did it this way. You took 600, because that's how many total, and you divided by 4. Because if it's uniform, they should all be the same, So that means that the 600 is divided into the 4 categories equally. And 600 divided by 4 is 150. You're always allowed your calculator, by the way. So 150, and this is a really easy question. How many would you expect in the South Shore? The hint is it's easy. Yeah, 150 again, because of, oops, 150, because if they're all the same, they should all be 150. Any questions on that? Okay, so notice what we're doing is we want to see if what we've observed is close to what we're expected or far from what we expected. Is that clear? Now, clearly, what we observed is not exactly what we expected because we expected 150 north and we got 170. Too many, right? But that's not enough to say that the distribution is not uniform because there's a sample. And hopefully by now you understand that a sample is not going to be exactly what you expected every time. Because if you did it a different day, you're going to get different numbers. Any questions on that? So the question is it far enough away from what's expected to be able to say it's too unusual for us to observe what we observed? So then we're going to reject the null hypothesis and say that no, the traffic's not equally bad. There's differences in the traffic in the 4 shores. Okay, I'm not going to get into all the details of the mathematics, but basically what it does is it says, is it far from what's expected or not far from what's expected? And if it's far from what's expected, then we're going to get a very low p-value because that's unusual. If it's close to what's expected, we're going to get a high p-value because that's pretty normal if what's expected is actually true. And that's kind of how hypothesis testing works. Any questions so far? Okay, let me do that. Okay, so now what I'm going to do is use my calculator. This is where I strongly suggest that you get your calculator out now because not all calculators work well. Okay, there's different calculators out there, and you can't even tell if you have a TI-84, it still may or may not work. They're not all the same. It's just frustrating. So what we're going to do now is pause share, go to the calculator. So whatever calculator you have, we're going to put in the data. And all calculators you can put data in. So I'm going to go to Stat, and you've done this before. Go to Edit. I'm going to clear out L1 and L2. And then for L1, I'm going to put the observed values. So 170, and then 212, and 110, and 108. I recommend you follow along with me. And then for L2, I put the expecteds, 150, 150, and 150. Any questions so far? Okay, now you cross your fingers in a big way and hope you have it. So here comes a moment of truth. Go to Stat. Go to Tests. Use the up arrow because it's at the bottom of the list or near the bottom of the list. So up is better. And you will see, maybe, chi-squared GOF test. So I just want to check, Morgan, Sean, Stephanie, and Linda, do you all have it or do you not have it? If you have it, you should be smiling. If not, then I'll help you, but it's hard. So Morgan, Sean, Stephanie? Sean, you got it? You have it? Oh, good, you have it. Okay, so those who don't have it, who are watching this as archived, I hope you don't wait till the last minute because it does take some work. If you don't have it, the easiest thing, if you happen to live in Tahoe, is come to my office. And what I can do is I take my calculator, this one, and I take the cord. Where's my cord? I take my cord and we mate the calculators. We let them touch each other, and then I send what I have into your calculator, and then you have what you need. If you don't live in Tahoe, I have a video on how to program your calculator, and you follow the step-by-step buttons to push. If you miss any little button, it won't work. And it's a little bit long, but it's not that terrible. So that's just a note. Okay, but the 4 of you, at least you have it, which is good. Okay, so if you have it, you click enter, and then it's really easy. Okay, observed. If it doesn't already say L1, you go second 1, and it'll say L1. Expected, if it doesn't already say L2, you go second 2, and that's what you want. DF. So DF stands for degrees of freedom. And the degrees of freedom for the chi-squared, GOF, by the way, stands for goodness of fit. We want to see, does the data fit what you expected or not? And DF is degrees of freedom. And the way you calculate it is very, very easy, is you take the number of choices for the answer minus 1. Okay, so how many different choices could there be for the answer? Yeah, 4. North, south, east, and west. That's 4. Subtract 1, and you get 3, and that's the degrees of freedom. Any questions on that? I don't really get the color thing. That's only if you're going to be drawing pictures and stuff. We're not doing it. So ignore color. Go to calculate. And there we have it. So it's pretty easy to use. And the interesting thing is, when they first came out with the TI-84, they didn't have this in it. That's what I was saying. So if you have an really old TI-84, you don't have it. The newer ones have it. All right. Well, at this point, we should be able to understand what's going on. Okay. The first thing is, you may not be able to read it, but that symbol is not an X. I know it looks kind of like an X. It's a Greek letter. And I bet you can guess what that Greek letter might be, given the fact I've said it about 6 times already today. Any thoughts? Yeah, chi. And it's spelled C-H-I, but you pronounce it chi, not chai. Again, I'm not sure why, but the Greeks tend to do it that way. So it's called chi-squared. And that is the test statistic. So we've seen Z for test statistic. That's for normal distribution. We've seen T for a test statistic, T distribution. And now we have a new one called the chi-squared distribution. So this is the third one. Any questions so far? DF is 3. That's what you put in. What is the p-value? Let's see if you guys remember from last week. How do we read that? Yeah, it's minuscule. So that E negative 11, don't forget to look at that. Tells you to move the decimal over 11 places. So it's 0.00000000056. Okay, that's as small as you'll ever expect to get. Okay, so note, always look for that E. If you ever write down a p-value that's bigger than 1, like 5.6, it's wrong. Okay, p is a probability, and you can never be bigger than 1. So just a note is that this is a lot of zeros and then a 5.6, 10 zeros and a 5.6. So if they asked you to round to 4 decimal places, your answer is 0. Okay. Typically in research, you never write down 0 for the p-value, even if it rounds to 0. You write down less than, and then you put a bunch of zeros in a 1. And you'll see that in articles. Any questions so far? Okay, now let me get back to the question at hand. So note that our p-value not gonna like this, 5, 6 it was. Okay, notice I didn't give a level of significance. Usually a level of significance is not given to you when you're doing research, but with this p-value, you don't need a level of significance, it's obvious. It's lower than anything you'll ever use. So hopefully at this point, you all know what the conclusion is when you have such a low p-value. What is it? Yeah, reject. And when you reject, it's really easy with the chi-squared because everything is already written for you because you say H1 is true, okay, in nice words, but you say there is statistically significant evidence to conclude that, and then you just write down H1, the distribution of shores by cars is not uniform. That's it. Most people like this chapter, by the way. So it's a good time to work on your project because it's kind of a lighter week. I tend to start fast and furious and then end slow. I don't know if you like that or not, but it's just the way I go, especially those who are taking other classes. Other classes get hard around now, so I kind of lighten up a bit. So this is a lighter week. Okay, did that feel not too hard? Okay, any questions at all on this? This is also, let me write down because it's important. If I ask you for, and I will ask you, the name of the test. It is the following: chi-squared goodness of fit. That's the test we use. So on the exam, I'll ask you what test did you use, and you need to write chi-squared goodness of fit. Chi-squared is not enough because we'll see we're going to have 2 other chi-squareds today. So it's chi-squared goodness of fit test. Any questions at all on this? Okay, you ready for another example? I'm going to erase, so last chance. All right, now let me get to the next one. All right, so here's the next question. A study was done to see if there's a difference in the distribution of cars for men and women. All right, maybe I was in a car mood when I wrote this out. All right, of the 200 men surveyed, 70 owned a foreign car, 110 owned an American car, 20 didn't own a car. Of the 300 women surveyed, 110 owned a foreign car, 158 owned an American car, and 38 did not own a car. Conduct the appropriate test, provide your interpretations. Any questions on the question? Okay, so this is different. See if any of you can see how this really differs from the last example. There's one main difference. And I don't mean like, did you own a car versus where were you on the lake, but what's the main difference in the study in terms of the data? Any thoughts? Again, you can talk or you can type it. Men and women in the study, 2 samples. Yeah. So here we have 2 different samples. We have 2 different distributions. And we want to find out if they really are different or not. And we don't know either distribution. We don't know the men's distribution. We don't know the women's distribution. Is that totally clear? Okay, so that's the main difference between this one and the last one. And it means that we're going to use something very different than what we did before. So let me write down H naught and H1. Okay, and by the way, the survey questions would be, what kind of car do you own? And for example, if they ask me, I own a foreign car. Subaru, kind of the car to have in Tahoe. So H naught is the distributions of car type are different, are the same for men and women. And once you have H naught, it's very easy to get to H1. Notice uniform doesn't work here, right? I have the same, but it's the same distribution for men as it is for women. It doesn't mean they're both uniform. Okay, in fact, clearly the not owning a car is a lot less likely, just looking at the numbers. H1 is the same thing, except instead of the same, is different. The distributions of car type are not the same or are different for men and women. Any questions on that? Okay, unlike goodness of fit, here what we're going to do is we're going to have the observed for men and the observed for women. There's no expected. So only goodness of fit has an expected. So let me put in a little table. And we have, let's see, foreign, American, and none. And then we have men. I'll just use M for men. And women. So how about W for women? So now we put in the numbers that were given. For the men, we had 70, 110, and 20. For the women, we had 110, and then we had 158, and then we had 32. Any questions so far? All right, now we're going to go to our calculator, and it's going to look really different than the last one. Like, really different. Okay, and I'm not joking. So let me go to my calculator. And I'm going to go to something that you've never seen before, or at least you haven't seen in this class before. Oh, I just made a mistake. There we go. Okay, let me clear what I had. So follow along. I'm going to go slowly so you can see it because, again, this is new. I'm not going to use the stat. I'm going to use second matrix. Any questions so far? Then I'm going to go to edit. Hit enter on A. Notice here we have 2 rows and 3 columns. So rows is 2, which it already is, and columns is 3. Any questions so far? Okay, now I'm going to put in my numbers, 70, enter, 110, enter, 20, enter, 110, enter, 158, enter, and 32, enter. Any questions so far? Okay, so again, doesn't this look a lot different than what we've done before? Okay, so then what we're going to do is we're going to go to Stat, Tests. We're going to go upwards. And we're going to go to the chi-squared test. Okay, and the test we're using is a test for homogeneity. I'll write that down a little bit. I hit enter. Observed is A. Expected is whatever you want. B works just fine. But A has to be observed because we put it in A. Color is never important. So it's very easy to use if you know what to do. But I don't think it's intuitive. Like if I hadn't shown you, my guess is you wouldn't be saying, oh, well, I'll just stick it in a matrix. You definitely need to see it done. And then I hit enter. And there we have it. So notice now we have our chi-squared is 0.266 or so. And we have our p-value is about 0.88. Okay, DF, they tell us, is 2, which we already knew, because there were 3 choices and -1 is 2. So it's interesting. For the chi-squared test, you don't need to put the degrees of freedom. But for the other chi-squared, for the goodness of fit, you have to. It just will give it to you. It gives it to you on the chi-squared test. Goodness fit, you have to give it to them. So 0.88 is our p-value. So any questions so far? Okay, so let me go to new share and go back to Paint. Actually, I don't need that big. So P was equal to 0.88. And while I'm thinking about it, let me write down the name of the test. And it's called the chi-squared test for homogeneity. So it's a chi-squared test for homogeneity. Homogeneity means the same. So the distributions are the same. Whereas heterogeneity means different. And now we have a p-value of 0.88. At this point, you better know what to do. What do you do when you have a p-value of 0.88? One more guess, Morgan? Yeah, it's fail to reject. P-value is very high here. When you have a high p-value, fail to reject. When you have a low p-value, you reject. Really, really important. Okay? Otherwise, you're doing the exact opposite of what you should do in terms of your conclusion. So what we can say is there is statistically insignificant. Sometimes you'll say insufficient, either way, evidence to, and then we can say support the claim, actually to, I like this way better, determine whether or not. And then you just state H0 or H1, it doesn't matter, because if you say whether or not, then both of them are kind of covered. So the distributions of car pipe are the same. for men and women. Any questions on the chi-squared test for homogeneity? Any questions? Just want to let you know, in the last example, when we rejected, or had we rejected this one, you only find out the distributions are different, or the last one we found out that the distribution was not uniform. This test does not tell you which is the one that is different. Does that make sense? Okay, it doesn't say it's the not owning a car, or it's the American car or the foreign car. Something's different, but we don't know from this test which one it is. Okay, in this case, we don't even know if they're different or not. But in the last one, we found out that it wasn't uniform, but we don't know how it's not uniform from this test. We just, like on this one, had we rejected, we just know that they're different, but we don't know how they're different. Any questions? There's another test to find out how they're different, but that is not beginning elementary statistics. That would be in the next class you would take in statistics. It's called the Tukey test. Any questions at all? Okay, you ready for another one? Let me know if you don't want me to race. Last chance. Gone. Okay, so now we're going to get into the next example. And I'm copying and pasting a table. I'm not sure if it copies and pastes right. It usually doesn't, but hopefully you'll be able to understand what it says. Yeah, sorry about that. Maybe I'll even stick in the lines to make it look a little better, although it's hard when I'm drawing, but that was an awful line. It never copies and pastes tables well. Those are better lines. That's how it should look. Okay, so here's the question. Is there a relationship between the day of the week a person is born and the type of smartphone they own? Okay, those people who believe in astrology might think there's a big thing, right? Because the day of the week you were born should determine your whole life, right? Okay, that might be the astrological symbol or something like that. Okay, a table below shows the results of a study that was recently done. Conduct the appropriate test and provide your interpretations. Just a disclaimer, I didn't really recently do a study, but I could have recently done a study. I have a feeling a lot of people don't even know what day of the week they were born in, but you could figure it out by knowing their birthday and how old they are. So we have the day of the week, and we have the type of phone. iPhone, Android, or other, I guess. Any questions so far? Okay, so now what we need to do is we need to come up with the right test for this. How is this different than the last two that we did? And this is very different, but how is it different? So the first thing is it's qualitative. That's the same as last time. But how is it different?
Asking for a relationship, if there is a relationship, whether they're dependent or independent?
Yeah, so it's about independent and dependent. And one big thing is it's two qualitative survey questions, right? The first question is, what day of the week were you born in? And I don't know what days of the week you were born in. I was born on a Thursday. I don't know if you know what day of the week you were born on. It was important then, but of course none of us remember it. And then the second question is, what kind of smartphone do you own? And other might be none, by the way. There aren't too many of them left anymore, the nuns. So it's two different survey questions, and we want to find out if there's a dependency relationship between the two. Okay, so in particular, the word independent is essential. because that's what we're going to be using for a hypothesis, for a null hypothesis. Whereas in the last two, the word distribution was the essential word. In this one, the word independent is essential. And I will be grading on that, by the way. So H naught, let's do it in red, actually, to distinguish it from the question. H naught is the day of the day of the week, sorry. Birth and smartphone type if that's one word, are independent. Any questions on that? And the hope is once you have H naught, H1 should be really easy. The hint is if you erase 2 letters, that's H1. Any guess on which 2 letters? Yeah, in. Because the opposite of independent is dependent. So the day of the week, birth, and smartphone type are dependent. Any questions on this? Okay, and notice the word independent will always go in H naught. The word dependent will always go in H1. And I will require that. I need to see that when on the final exam, by the way. Okay, because this could be on the final. All right, so now what we can do is we can go to our calculator. The interesting thing is that the hypotheses are very different. What you're looking for is very different compared to the last example and the one before. But the math is exactly the same. You just have to trust me on that. So because the math is exactly the same as homogeneity, we're going to use the same calculator functions. So let me go ahead and share the calculator. All right, so I'm going to go to second matrix. I'm going to go to edit, hit enter. Here we have a 3 by 7. So I'm going to go 3, enter, 7, enter. Any questions on this? And then what we're going to do is we're going to start typing our numbers. So we have what? 75, enter, 72, enter, 68, enter, 77, enter, 70, enter, 86, enter, 80, enter, and then we have 120, enter, 111, enter, 131, enter, 125, enter, 118, enter, 124, enter, 101, enter, 45, enter, 52, enter, 44, enter, 50, enter, 57, enter, 46, enter, and 52. Enter. Any questions on that? Okay, so next, we're doing exactly the same as homogeneity. It's the same math, even if it's a different test. We're going to go to stat. We're going to go to tests. I'm going to go up arrow to chi-squared test. Hit enter. A and B are just fine. And enter and calculate. There's chi-squared. I want to note something. Chi-squared is 9 point something. This is very different than z. If z were 9, your p-value would be tiny, tiny, right? Okay, or t. But here, the number that you get for chi-squared, it's a lot harder to read and know what you get for the p-value just from the number. Okay, but the p-value is about 0.7. Any questions on that? Notice the degrees of freedom is a little harder. It's 12. I'm not going to go over that, but you can believe me or believe the calculator. So I want to show you one more thing. If I go to matrix, I want to go to B, and I think enter, and enter again. If you look at these numbers, they're all bigger than 5. Okay, and you can trust me that they are. I can look at them all, but they're all bigger than 5. That's what you need in order to be able to use the test. So that's a big enough sample size. Nothing to do with 30, but you have to have all the entries of the matrix are bigger than 5. And same thing for the homogeneity. And for the good as a fit, you have to make sure that the expected values are all bigger than 5.
And you found that in the matrix?
Huh?
Where did you find that?
How did I get B? I went to matrix, and then I went down to B and click enter. Maybe enter. Yeah, I think enter just once. Okay. And they're all bigger than 5, and that's what you need. If you have anything that's 5 or less, then this test isn't okay. Sample size is too small. Okay, the formula to get these numbers I'm not going over. You won't need it for the test. But I do want you to know you need expected values. This is called the expected matrix. And you need an expected matrix with every entry bigger than 5. Okay, so now I'm going to go back to the sharing. And let me write down the test. Actually, let me write down, remind you that the p-value was about equal to 0.7. On your assignment, you're probably going to be asked for 4 decimal places, so make sure you do that. On the final, I'm good enough. Oh, sorry, it was not 0.7, it was 0.7. On the final, I just want good rules of rounding, and you're good enough. Okay, the name of test is the chi-squared test for independence. Any questions so far? Okay, we're almost there. So now we have a p-value of 0.7. What is the conclusion? At least in a few words. And then I'll put on the longer words.
Failed to reject.
Yeah, we failed to reject. So if we fail to reject, we say there is statistically, let me write the other way, there is insufficient evidence to make a conclusion about whether and then you just write this down, the day of the week, of birth, and smartphone type are, and how about independent? If you say whether or not, actually about whether or not, sorry, are independent. If you say whether or not, you can say independent or dependent is fine, because whether or not takes care of both. And that's it. Any questions? Any questions on this idea? Any questions? Okay, so we've gone through 3 tests. We've gone through the chi-square test for goodness of fit. and that's to test whether a unknown distribution is something that is known, like uniform. What's another big distribution you might want to test for? In one word. Any thoughts? It's the most important distribution of the whole class.
Normal distribution?
Yeah, normal. Sometimes you test to see if it's normal. Okay, and another distribution you might be testing for is some known distribution, maybe what happened last year. Or maybe you have data about America and you want to find out if Tahoe is different than America. Does that make sense? And you know all of America because that's been published or something. So that's typical. Or maybe you're a biologist and you have some new GMO crop and you want to find out if it has the same color for their tomatoes or something of the 4 different tomato colors you can get compared to the standard ones that we all know about. Does that make sense? So there's lots of different things you can do for goodness of fit. Homogeneity is to test to find out if 2 unknown distributions are the same as each other. And independence is when you have 2 survey questions and we want to find out if the answers to the survey questions are independent or dependent. And these survey questions need to be qualitative, like what day of the week were you born in? All right, so let me give you the secret word of the day, of the week. And it is goodness. Because we've talked about the goodness of fit test. And I thought goodness is a nice word. Okay, so I don't have like, a review of a test or anything to talk about. So this is not as long as the last few actually been when we talked about the project and we talked about the midterm. But if you have any questions, I'll be happy to answer.
Were we supposed to keep our test? She kept my test.
But she can do whatever she wants with it because I already posted the key.
But I don't have my test to see.
So if you want it,
can you email it?
I can email it to you.
That'd be awesome.
But please send me an email to remind me.
Okay.
I never remember requests during webinars because I'm too busy doing the webinar. But if you send me an email to remind me, then I can forward the test to you.
On question number 8 for this week, the Kai.
Okay, remember everyone gets a different question number 8. So
what?
You do realize that other people's question 8 is different than your question 8.
Right, but one of them has for the H0. Take a peek at one of, and I didn't get the first part of it, but one of them has 5 instead of 4 options, and 2 of them are identical.
Oh, really? I
got one wrong. I just redid it, but
okay, that's probably my mistake, or our mistake on programming.
No big deal. I just thought
no, it is a big deal because I want to fix it.
Okay.
Because remember, there are thousands of students now. This thing is blossoming.
What do you mean?
All over the state.
Oh.
Using this.
Okay.
So we want to help everyone if you want to be a good Samaritan. And there's going to be more. I get emails every week saying, "How do I get this thing that you guys built?" Yeah.
Okay. Yeah, it's on, and I only took a picture of the when it was on students and work study.
Yeah, if you can send me either post on the Q&A or send me an email, and then I'll fix it.
Okay, I'll email you because I just took a picture of just that one little tiny piece. So sorry.
Yeah. Especially if you've redone it.
I redid it.
If you redo it, I can't see because then you'll get a different question.
Yeah, I did.
And then I won't know what it was.
All right, sorry.
Because I can only see the last one you did. No, that's fine. Just send me an email saying just a few words, and I'll be able to find it.
Okay.
That's all I need.
Okey-dokey.
But I need a little information to be able to find it.
All right, I'll send you a copy of the picture.
If you don't redo it, that's fine too. But if you do redo it, then I need a little more information. Because I can go back and look at your last attempt.
Okay.
But not your prior attempts, is the way this program works.
I only attempted it twice. First time I got it wrong because it was the top one, not the bottom one, I'm guessing, because it was the correct answer. But anyway, so I just redid it. So.
Yeah, so I'll fix it. I know, but it'd be nice if you don't, I don't frustrate thousands of people.
Yeah, okay.
I don't want to do that.
All right.
But thanks for letting me know, and then I'll fix it.
Yeah, this is a really fun chapter.
Oh, good, good.
Really fun.
Good, good. Oh. Yeah, it's useful.
Yeah. Okay. All right, I think that's it.
Okay.
How long is the paragraph for type 1 and type 2?
What's that?
How many sentences? If we cover for the type 1, type 2 in the project, if we pretty much cover what type 2 is, how we come up with the level of significance, and what can be right and or wrong, and what it means, what is, I mean, how long is each paragraph?
And what kind of damage is done.
Right, that's what I'm saying, the repercussions.
Yeah, and then go back later
and rethink.
After you have either rejected or failed to reject, and then revisit it.
Okay, I already did. Okay.
And then you could talk about how likely it is, because now the likelihood is different. Before you start, the likelihood of a type 1 error is 5% if you use 5%, or 10%, or 1%.
Right.
After you decide on your p-value, then one of the errors won't happen, didn't happen.
Right.
And the other error is either somewhat likely or not likely at all.
Okay, doke. All right.
Depending on your p-value. So that's a little more to talk about. Does that make sense?
Yeah.
But good question.
Okay.
Anything else?
Thank you. That was it.
Okay. Well, have a good night then.
Thank you.
Time to ski home.
Oh, that is not fair.
It is. Finally, we have powder.
All right. All right. Thank you. Good night.
All right. Good night. And for all of you who are watching this as an archive webinar, thanks for watching. And please, if you can't figure out how to use your calculator, especially if you don't have the GOF, then I'm happy to help you out. So have a good night.